So lesson 4.7 is inverse trigonometric functions. When you look up there on the screen or on your notes, notice it says y equals sine to the negative 1x. You remember that button I said don't use when we're doing the reciprocal? The second function of sine, cosine, and tangent? That's what this is. It's different from the reciprocal. It's called the inverse. Now, think about it. When we have done inverses, we've done inverses back in as far back as Algebra 1. We've reviewed them in pre-cal, though. When we find an inverse, what do we do to find the inverse? What do we do with our x and our y? We switch them. Okay, when we talk about inverses, my Algebra 2 kids have been talking about inverses. Okay, you take x and your y, so you take your input and your output, and you switch them. Okay, that's what inverse is. And so that's what, when we look at these inverse trig functions, which we're going to focus on sine, and then at the bottom we'll talk about cosine and tangent. So the inverse trig function for sine takes your input and your output and switches them. So normally, if I ask you, I might ask you the sine of 30 degrees, right? Or the sine of pi over 6 if you prefer. So the input there is your angle. So the 30 degrees or pi over 6. What is sine of 30 degrees? What? Okay, 1/2 is what I would say. 0.5, same thing. And so that's your normal output, right? So sine inverse would ask you, what is the sine inverse of 1/2? And the sine inverse of 1/2 then is going to be the 30 degrees or pi over 6. So your input and your output will switch is the idea. Now, obviously there's a few more tricks to the trade and all of that along the way, but that's the general idea of what we're looking at. Okay, so in the notes, most common that you'll see is y equals sine to the negative 1x. However, before I proceed any farther, you will also see, and I believe it happens in this book, that is equivalent. If I write y equals arc sine x, that is the exact same thing as saying sine to the negative 1. So saying that sine negative 1x. And I believe, this is on a double checking, yes, they use both in the homework. So you'll see sometimes they'll use the negative 1 there between the trig word and the variable. And you'll see other times where they say arc sine x. Okay, so let's talk a little bit about domain and range of this. Domain of a sine function. Okay, so of course domain means your what? Okay, your x values, your input values, right? So the domain of the inverse sine function is negative 1 to positive 1. So when you are putting values into an inverse sine function, they have to be between negative 1 to positive 1. If they are outside of that negative 1 to positive 1 interval, then you can't do the inverse sine of that number. Okay, it's just not possible. Okay, so all values inside the inverse sine function will be between negative 1 and 1. Range. Well, range, we tend to think y, right? Range is your output. Well, keep in mind now, range is our output. Our output is going to be our angles, right? The 30 degrees, the pi over 4, the 60 degrees, you know, all of those. And so the range is specifically negative pi over 2 to positive pi over 2. And so that's saying that all answers for the inverse sine function must lie within this range. So between negative pi over 2 to positive pi over 2. Now, is negative pi over 2 to positive pi over 2 all the way around the circle? No. All the way around the circle is what? 0 to 2 pi. So if we're talking all the way around the circle, we have to have some kind of interval that's equivalent to 2 pi. Notice this one is not. Okay? Our range, so where our outputs for sine are allowed, is negative pi over 2 to positive pi over 2. Flip your notes over to the back side for a moment. You have a page with 3 half circles, yes? Okay, these are important. And I was just talking about what you're going to be allowed to have on that unit circle with some notes, so to speak. And you'll understand more about these half circles as I go along. But these half circles are something you can put in your notes for the chapter test. So you can use them along with the unit circle. So notice the first one there that we're talking about right now is the sine inverse. And what this half circle represents is this represents the range values. So we just said the range of sine inverse is negative pi over 2 to positive pi over 2, correct? This half circle represents where your answers can fall. Which notice, where can my answers fall? Only on the right side of the circle, correct? Okay. You get something over here, that's not possible. And again, this will make more sense as we start going through some examples. Now, what is pi over 2 the same as in degrees? Pi over 2 is how many degrees? Pi over 2 is 90 degrees. If positive pi over 2 is positive 90 degrees, what is negative pi over 2? Negative 90 degrees. So basically what we're saying here is that all of our answers for a sine inverse problem have to be somewhere between the value of negative 90 to positive 90 degrees. Now, do we typically think of this as negative 90? No, we typically think of this as what? 270. That means if you try and tell me an answer of 270, I'm going to have to say no. What's another name for that? So, like right here, we would normally call this what? 330? If I have my numbers right here, if I'm in the right spot, we would normally call this 330. Well, I wouldn't want you to tell me 330 for an inverse sine problem. It's how far below? It's negative 30. Okay, so this would be negative 30, negative 45, negative 60. Instead of using the names 330, 315, and 300. Okay? And again, I'll talk you through this, but I'm just trying to explain what you're seeing here. Got it? So all of our answers fall in quadrant 1 or quadrant 4. And think with me real quick. What do you know about sine? In quadrant 1, sine is what? Positive. So all my positives are up here in quadrant 1. What do you know about sine in quadrant 4? It's negative. So all my negative answers are in quadrant 4. As I'm thinking about it, there's something else that you could put on your paper, right? Your little quadrant, all students take calculus. Your little, I want to say your little cheat thing there, but it's not really a cheating. It's just your memory technique. How's that? There we go. It sounds so bad when the teacher calls it a cheating thing. It's not really cheating. It's just it's a memory aid. It's something to help you. So, okay. So as I go back to the front side, next comment there, and this is just kind of a reminder, I've already talked about it. The answer to the inverse sine function is an angle. So every time we talk about these inverse functions, our answers are angles. So instead of putting the angles in, we get the angles out as our answers. Okay. Do you have your charts by your side? And honestly, you could use your quiz if you have your quiz sitting there too. Okay. And this is where it's going to be helpful to get that chart on the bottom of your unit circle. Let's look at example A. Now, notice the directions. Find the exact value of each of the following without a calculator. Anytime they say exact, you don't want a rounded answer. Okay? So like on some of these answers that, how do I want to say it? We don't want to round anything, okay? We want an exact answer, which often means not using a calculator and using more of our brains. So A wants us to know the sine inverse of 1/2. Now, first thing that doesn't hurt to check, okay, what's my domain value here? What is the input that they gave us? 1/2. does that fall in the domain of what is allowed for inverse sine? Yes, because inverse sine is allowed -1 to +1. 1/2 is obviously in that domain. Okay, so our output is going to be our range. How I would ask myself this is, when does sine equal 1/2? At what?
30 degrees.
At 30 degrees? How do you know that? Okay. It's something you should be working on memorizing, but I'm not going to stress you about memorizing that right now. It's on the chart, yes? Okay. If you go and, where's mine? Okay. So, when does sine equal 1/2? Sine equals 1/2 at 30 degrees. What is that in radians? Pi over 6. I'm going to give my answer in radians. Because it was positive 1/2, I'm going for just a typical quadrant 1 answer. And A is done. That's a good question. I don't remember. On the homework, I think you need to stick with radians here. Okay? So the question was, can you say 30 degrees also? I think what we need to stick with, unless it says to express your answers in degrees, go with the radian answer. Okay?
Can I please have another unit circle? I think I lost it somewhere.
Of course.
And I quite struggled about it.
Anyone else need another unit circle? I think you just opened up a good question there that I had not thought to ask.
Thank you.
You're quite welcome. And as you guys may or may not remember, I have a whole pile of these guys copied up there. So at any point, if you can't find it, you just want a new one to start fresh, I've got them up here. Okay? Yeah. Or if you just like, now that Mrs. Sargent said, oh, we can use these, we can write on these and make them ours for the test, and now you're thinking, oh, I want to start over, you can have another one. Okay, questions on it? You can agree that the sine of pi over 6 equals 1/2, right? That's what, and so we were saying, when does sine equal 1/2? And that was pi over 6. Okay, let's try B. It's sine inverse of negative square root of 3 over 2. So, first of all, one thing I want you to check. Is this a good domain value? It's negative. Well, and what domains are we allowed to use? Our domain is allowed to be -1 to +1. Does the square root of 3 over 2 fall between 0 and 1, basically? And it's what? 1.7 divided by 2, so it's less than 1. Okay, so our domain value is good. Now we've got to come up with the appropriate range value, so the output. So now, here's my recommendation. I would start with, forget the negative for a moment. Okay, the negative just tells us what quadrant to put it in. But start with, when does sine equal square root of 3 over 2 according to our chart? Okay. Sine equals square root of 3 over 2 at 60 or pi over 3, yes? And I don't care what you guys say in class, but realize what if I'm going to write down? I'm going to write down a radian answer, right? Now, keep in mind, that is if we are in quadrant 1, correct? We just said pi over 3. So in quadrant 1, it's pi over 3. But is sine ever negative in quadrant 1? No. So our answer is not going to be just pi over 3. Okay, so think about this. That was 60 degrees or pi over 3 up from the x-axis. What is equivalent down in quadrant 4, which quadrant 4 is where our negative answers are, right? What is equivalent to positive 60? Okay, 300 degrees, yes. Except, you can't give me that name. And I'm not talking about because it's degrees. Okay, and I'm not wanting 5 pi over 3 either. Okay, so this falls into that tricky, remember the back side of your notes, right? That, notice, is this labeled as 5 pi over 3 here? No, it's labeled as negative pi over 3. So if it's positive pi over 3 up, then it's negative pi over 3 down. Or, that's why I also like to talk degrees, right? Positive 60 up, it's 300 degrees is 60 down, correct? Okay, it's 60 from 360. So down here, we're just going to use negative pi over 3. 5 pi over 3 is equivalent, but not an official allowed answer. Am I making sense there? The half circles? Yes. Mm-hmm. So what is the sine inverse of negative square root of 3 over 2? Negative pi over 3. And if I could try, I know there's not a lot of room here, but if I show you a little bit of visual, right? First of all, remember my answers have to be over here on the right. There's no answers on the left. We started with positive pi over 3, but we needed the negative equivalence, which is negative pi over 3. Which the good news is about sine, if it's in the upper quadrant, you use the normal positive one. Down in quadrant 4, you just basically take the same thing and put a negative sign on it. Okay? Cosine will be a different challenge. We'll talk about that when we get there. But with sine and tangent, basically instead of giving a positive answer, you tag a negative on the answer. Yes, Jace?
And that's just going to stay true. As long as there's a negative in the parentheses, it's always going to be part of the whole part.
With sine and tangent, yes. Okay? As I said, cosine's a whole different beast, so we'll get there later. But okay. Questions there? Okay, let's try C. Sine inverse of pi over 2. So first of all, what have I been asking you to do every single time? Does the domain work?
In this case, no, because pi is 1.14.
Is there truth to what he said there? Pi is 3.14, and you take 3.14, and you divide it by 2, and that's 1.57 something. Is that an appropriate domain value? No. What's our domain value supposed to be? -1 to +1. So the fact that here's what they're trying to do. They're trying to trick you. Okay? Because they're trying to, when you see pi over 2, you think of it as an angle, right? Hopefully you're getting to the point when you see pi over 2, you're thinking, okay, that's at 90 degrees. Okay? I said getting to that point. So, but they're trying to make you think, oh, well, what's the sine of 90 degrees? But that's not what they're really asking. Pi over 2 is just a number here. And so if pi divided by 2 is approximately 1.57 something, well, unfortunately, 1.57 is greater than 1. And so, guess what? Sine inverse of pi over 2 does not exist. And why does it not exist? Because that pi over 2 is outside of our domain value, or our domain interval. Okay, so I will put that down here, because outside of domain. So you have to be very careful there. And needless to say, that is why every stinking problem I've been asking you, check the domain, check the domain. Okay? If you were trying to plug this into your calculator, you would get an error. Okay? And we'll talk about plugging them into the calculator here in a moment. Okay? In the meantime, let's talk about D. Sine inverse of sine of pi over 3.
No problem.
Sorry, I was watching you just kind of shake your head at me like, yeah, no. I can tell it's the I got nothing shake. Okay. I'm going to say, you see parentheses. As a math student, when you see parentheses, what do?
You do it 2 times first.
You start inside the parentheses, right? So if I say, let's start inside the parentheses, the inside parentheses are asking, what is sine of pi over 3? We are in lesson 4-7, my dear. If that gives you any indication of where we've been. And I would recommend going back and watching the video later because it's going to be hard jumping in the middle, but try and pick up what you can while you're, Okay, so sine of pi over 3. Notice, is that sine inverse? No, it's just sine of pi over 3. You have your chart? Or do you have it in your brain? What is the sine of pi over 3? What is the sine of pi over 3? Square root of 3 over 2. So what do I replace sine of pi over 3 with? Square root of 3 over 2. Now, that replaces the inside. The outside still says sine inverse. So now,
So you just do it backwards, right?
so now we've got a whole new problem to work, and this is just like A, B, and C. Okay? When does sine equal square root of 3 over 2?
What do you mean when you said pi over 3?
I don't know how we do have this.
Yeah,
I feel like you can just do like a quick calculation.
yeah,
That would make too much sense.
In this case, it seems like extra steps, but there are times when your answer is not going to be exactly the same. Okay? So bear with me on the extra steps. I see your point. I totally get where you guys are coming from over there, but it's not always going to be the same. Okay? So, the sine, when does sine equal square root of 3 over 2? At 60 degrees or pi over 3. And what was this asking? When does sine equal square root of 3 over 2? 60 degrees or pi over 3. Now, okay, so rightfully so, I have people recognizing that, oh, the sine inverse, the sine cancel each other out, it's just the pi over 3. And yes, to an extent, a function and its inverse will, and I probably should use the word cancel there. I don't have the right word off the top of my head, but yes, they will undo each other, okay? However, throw in a negative there or something, and our answer won't necessarily match up. Or throw in something outside of the domain, or, so I would always encourage you to think through that initial step. Don't just skip over it, okay? Well, and, okay, so I guess what I'm going to say is put your thoughts on hold, because the next one I'll prove why you have to think through the steps. Okay? How's that? Did we kind of follow here? We started with sine of pi over 3. Our chart says, oh, that's square root of 3 over 2. Then we do sine inverse of square root of 3 over 2. So when does sine equal square root of 3 over 2? And that is pi over 3. Now, On E, automatically, how do I know I can't just cancel these out? Yeah, 5 pi over 6 is not in quadrants 1 or 4. And my answer to a sine inverse problem has to be in quadrants 1 or 4. 5 pi over 6 is in quadrant 2. It will, give it a chance. We have to work through it in steps. And once we take care of the first step, it will get us to the next step. Okay? So last time, I get it. They ended each other, all's good. This time, okay, sine inverse of sine of 5 pi over 6. Again, we see multiple parentheses. We start inside. So you're going to your chart. Actually, no, we can't go to the chart. 5 pi over 6 isn't on our chart, is it? Okay, so if you have to find the sine of an angle not on your chart. Yep. Okay, so this is where, and I'll use the unit circle for a moment. Okay, 5 pi over 6 is where? Quadrant 2. I need a reference angle there. I need to convert this to pi over 6, pi over 4, pi over 3. How far is 5 pi over 6 from the x-axis? It's always the x-axis. So how far is 5 pi over 6 from pi? 1/6, yes? So pi over 6. So when it says, what is the sine of 5 pi over 6, it's really saying, what is the sine of pi over 6 in quadrant 2? Well, what is the sine of pi over 6? According to our chart.
30 degrees.
No, pi over 6 is another name for 30 degrees. The sine of pi over 6, according to our chart, is 1/2. What do you know about sine in quadrant 2? All students, so sine is positive. So what we're saying right here is that sine of 5 pi over 6 is positive 1/2. Because it's equivalent to pi over 6 in quadrant 2. So my new inside value is 1/2. And when does sine equal 1/2? That's what sine inverse is saying. Okay, according to your chart, sine equals 1/2 at pi over 6. Making a little progress. There's a lot to think about, but it doesn't help that we've had this week and a half or whatever off from our regularly scheduled trig stuff. I know that makes it hard to come back, but yes.
I understand now what you're saying. If you started working in radians earlier, because you can kind of like, there's not so much skipping a step, but you can subconsciously do a step thinking of this in radians. Because when we got the reference angle, it equaled the same as the reference angle.
It did, yeah. Mm-hmm. Okay, we do have a little f thrown in there. Sine inverse of -1. So this is just back to a typical sine inverse problem. So I'm asking, when does sine equal -1? Now, if you guys are looking at your traditional charts, right? You have those 3 rows on your charts, right? And is sine 1 or -1 on that? Okay, so we're out of luck there. Remember the zeros, ones, -1s? Where did those put us?
Oh, it's right on one of these.
Yeah, it's the 90 degrees.
It put us on the,
It's gonna be negative.
what they call quadrantal angles. Okay? Put us on the quadrantal angles. Remember, an ordered pair is, I had it written on here, that's something else. I didn't grab the right, I've got too many unit circles laying around up here, but an ordered pair is cosine, sine. Cosine, sine. Cosine, sine. Cosine, sine. What was I looking for? When does sine equal negative 1? When does sine equal negative 1?
Negative 9. Or negative 5.
Okay. Okay. So now, and I don't know if anyone said it because, I heard multiple people at the same time. If you're looking directly at this, you might say 3 pi over 2, yes? And that's not wrong totally. However, I can't give you that full credit there because it's not following our half circle. Remember, it has to go from negative pi over 2 to positive pi over 2. So another name for 3 pi over 2 is the negative pi over 2 that I heard several of you say. Okay? So if you want to, you can say for a moment that it's 3 pi over 2, but realize the answer I need is negative pi over 2. And I need that answer because this one is not in the range. Okay, so that's why we can't use that 3 pi over 2 as a final answer. I have no problem if your brain thinks that, but then you have to convert it. And remember, you can always just subtract 2 pi to get there. Now, I'd like to, I think we can do it, do the calculator portion of sine and finish up sine real quick. Got your calculators by your side? Because notice example 2 says, use a calculator how? In radian mode. Okay, so use a calculator in radian mode. Now, and this is, guys, unless you know you're putting degrees in, all trig functions automatically work in radian mode. Okay, so the default is radian mode for this class. I don't care what your physics teacher says. That's physics. Okay? So in my class, the default is radian mode. Okay, I told you earlier, I had vetoed the second sine, second cosine, second tangent buttons on your calculator when we were doing reciprocals because they are inverses. So here we go. Second sine of negative 0.81. There you go. Does your answer match my answer? Okay. So I have written down 3 decimal places on my paper. So I have negative 0.944. Got it? I know, not a challenge to use the calculator here, is it? But again, you're going to get all wrong answers if you're in degrees. Or in this case, if you try to do sine to just the negative 1 power by hand, you're going to get wrong answers. You have to use the sine inverse button. Okay, real quick, B. Can you do it? Second sine inverse, and then a regular sine, and then 3.49. Please use the pi button. And officially, you could get away without punching your end parentheses there. Does your answer match my answer? Negative 1.539. Okay, guys. Wait, I finished the time to spare? Is that possible? But it's a good breaking point, okay? Tomorrow, we will talk about cosine and tangent. Now, your homework that is listed on the board is page 385, 1 through 20, and 23 through 32. Obviously, that assignment goes with the entire lesson. Have I taught the entire lesson? No. So, is the assignment due tomorrow? No. Now, can you start some of the assignment? You can if you want to skip around. Because they don't have a section that is just all signed. It's all jumbled up. So, if you want to start while this is fresher in your head and you want to try it tonight, you will have to only skip around to the sign problems and skip the cosine and tangent. Or you can wait and do it all at once. Okay? It's totally a personal choice there. But, okay? Questions for me there?
No, we just went over the